Hello there. In this video, I am doing a hydrostatic pressure problem. And this is the dam problem, which I believe is number 10. And there is another one similar to this in the homework. So let's get started. The Deligning Dam on the Cayley River is built so that the wall facing the water is shaped like the region above the curve y equals 1/2 x squared. And below the line, y equals 260. The water level is 32 meters below the top of the dam. Find the force in newtons exerted on the dam by water pressure. So the first thing I want to do is draw a picture of what is going on. As always with application problems, that is very, very important. So this is actually a parabola. You should recognize this as a parabola. I'm going to do my best to draw a parabola. Ooh, that's not too bad. And then the line y equals 260. Let's just put that right at the top. All right, so this is 260. Y equals 260. And we're going to need, I believe, to find these points right here at some point. And because this is a function, y equals x squared, and anytime I'm doing a problem with a function, I like to orient my vertically as a y variable and anything horizontally as an x variable. So therefore, what I am going to do is I am going to say, okay, let's let this distance from here to here, the bottom of the dam, be y. This is my distance y. And so down here, I am going to let y be equal to 0. And the reason I'm going to let y equal 0 be at the bottom is because I like that to be, I'm going to pretend that this is the origin and that I have a vertical axis, the y-axis coming through here, and that we have basically the x-axis coming through here. I'm just going to kind of dash those in there. So this is x equals 0. This would be y equals 0. Okay, so if this is y equals 0, this is going to be y equals 260. Well, let's, now we got a little picture of it. Let's take a look at what we need to do to solve this problem. So our basic force integral is the integral from A to B of density times acceleration due to gravity, which is g, times the width and times distance or depth. The distance is also the depth. And so we can kind of abbreviate this a little bit because remember, density is going to be given to you. It's a constant. G is going to be given to you. And generally speaking, G is going to be equal to 9.8. And if it's water, then the density is going to be 1,000. And we've used the units before, 1,000 kilograms per meters cubed and 9.8 meters per second squared. So the force then is reduced to rho times g, the integral of a, b, and we use the width, we'll call that a width function, wx, and the depth function, I would use d of x, but the textbook, to be consistent, uses s of x, in case you're reading the textbook. All right, so the first thing we need to do is find the width. So we're going to take a slab of water somewhere, just like we always do with every problem. We take a slab of water. All right, and so this distance right here is the width of that slab of water. Well, it's going to be easiest to find this distance right here. Okay, that distance right there is going to be some type of an x value. So if we take a look at this point right here, all right, that's going to have an x value and a y value. And so this distance right here, because this is the, this right here is the y-axis, remember, then this distance right there is going to be an x value. But how do we represent that x value? We want to represent this in terms of y. So we have to go to our function. Y is equal to x squared. or x is going to be equal to, oh, I almost forgot. This is 1/2 x. Nobody caught that, did you? You probably did. You said, hey, Mr. Strong, put the 1/2 in there. So we have 1/2 in here. All right, so that means that we have x squared is equal to 2y, or x is equal to the square root of 2y. All right, so that is basically what this x value is going to be equal to. It's equal to the square root of 2y. And so the width, the entire width, remember the width up here is going to be twice the x value. So the width function, w sub x, is going to be 2 times the x value, which is going to be 2 times the square root of 2y. Okay. The next thing that we need to find is s of x. So let me find s of x over here. I'll just kind of squeeze that in over here. The depth function. So this slab right here, this slab, how far below is it? Well, or how far, basically, how far, we want to know how far it is from the surface. Yeah, that's how far it is from the surface. That's the depth, okay? So when I say the distance, I mean depth, as I said earlier, depth. So the depth is the distance down from the surface, right? So that's the distance from here to here. Well, if this entire distance right here is 260, and we're measuring y equals 0 up from the bottom, then this distance here is going to be a y value. And so this distance here is going to be a 260 minus y. This is why we had to put the function in terms of y, because this is going to be in terms of y. So we need both functions to be in terms of y. So 260 minus y. All right, now it's just a matter of putting it all together into our integral. That's the hard part, getting it all set up. Don't you love these application problems? So the force is going to be equal to 9.8. That is my acceleration due to gravity. My density of water is 1,000 times the integral, and we'll get the bounds of integration here in a second. And so the function is 2 square root of 2y, and we had 260 minus y, and we'll integrate with respect to y. Now, what are the bounds of integration? So the bounds of integration is where we have water. Remember with these problems, it's where we have water. Well, we don't have water from the top of the dam to the bottom of the dam, do we? No, if we had water all the way up to the top of the dam, then we would be going from y equals 0 to y equals 260. But I do believe it says that the water level is 32 meters below that. So the water level, let's see, do I have another color? I'm going to use a marker. So here's where the water level is right there. Okay, it's like right at the bottom of that. So water level is 32 meters down. So this is 32. So all we have to do is subtract the 32 from the 260. So 260 minus 30 would be 230. So what's that? 228. So the bounds of integration, we are integrating from y equals 0 to y equals 228. I have that funky. All right. Well, that's the hard part. I believe that everybody can probably deal with this from this point on. But let's just kind of clean it up a little bit. I always like to at least leave you with the simplified integral, because that's what I'm looking for on the exams. 0 to 228. By the way, if I make a mistake, like an arithmetic mistake in these videos, please let me know. So this becomes, I'm going to separate the radical 2 from the radical y. So I have 2 radical 2 and a radical y. You know, we can do that. Well, actually, I don't want to do that yet, do I? I want to multiply these through. Got to multiply those through. So 260 times 2 is 520 times radical 2y minus 2y radical 2y. So there's a little bit of algebra here. Ooh, there's the algebra word. And so what can we do now? What can we do? What can we do? What can we do? Well, I'm going to factor out from each of these the radical 2. Because the square root of 2y is the square root of 2 times the square root of y. So this would be 520 radical 2 times y to the 1/2. You can probably see why I'm doing this. And this is 2 radical 2 times y to the 1/2. And we're integrating all of that. And let's see, we've got, yep. And so we have the 9800 out here, 0 to 228. So I'm going to just integrate this radical term by term. So we have 9800 times the integral from 0 to 228 times 520 radical 2. And then we have y to the 3/2 times 2/3 minus 2 radical 2. Now y times y1/2, this becomes y to the 3/2. Okay, and I'm actually integrating, so I don't need that there now. I wasn't planning on integrating in this step, but I kind of just jumped ahead of myself here. So y to the 3/2, so this is going to become y to the 5/2 times 2/5. And then we're integrating that from 0 to 228. All right, and I should just check my work over again. That's probably with these videos is I hate checking my work. But I only know there's like 5 people who are going to watch them. So all of this then can be evaluated at 228. This can all be evaluated at 228. And, you know, when you evaluate at 0, it's just going to go to 0. So that would then be your answer. Okay. Now I have an answer in my notes, a final answer, because I plugged it into Desmos and got it, of the force is big long number 78102.124. I think I'm getting all these digits in it. 80.2. Let's see. So comma. That's a really big number. 7,810,212,480.2 newtons. Alrighty, so watch the video. Let me know if you have any comments on the video. And again, if I made an arithmetic mistake, because I'm going to go back and watch it, and if I see an arithmetic mistake, I'll probably have to redo the darn thing. But if you see it before I do, go ahead and let me know. But the important thing is this is how you set up this problem as a hydrostatic force problem. Hope it was helpful. See you guys in class.